Okay, in section 3.2, we're going to do number 7. And number 7, the directions say, find the two x-intercepts of the function f, and show that f prime of x has to equal 0 at some point between the two intercepts. So the derivative of x has to equal 0. So there has to be a critical point at some point between the two x-intercepts. Okay, so first off, let's find the roots of this function. So where is this function equal to 0? So this is at, so f of x equals 0 where? For what values of x? So that's wherever x times the square root of x plus 4 equals 0. Okay. One trick that we can do here is we can assume that, yes. Well, that's going to be, since we can use the zero product property on this, which states that if I have things that are separated by multiplication, right, and I have this quantity, this factor here of x and this factor of square root of x plus 4 separated by multiplication, I can use the zero product property in order to say that this will be 0 whenever this quantity is 0 or whenever this quantity is 0. So my function f has roots at a value of 0. So f of 0 will be 0, and at a value of negative 4, because negative 4 plus 4 is 0, and square root of 0 is 0. So, and at negative 4, that is equal to 0. So both 0 at x equals 0 and at x equals negative 4 are my roots of this equation. So let's set up an interval from 0 to, be the other way around, from negative 4 to 0. Now Rolle's theorem states, let f be a continuous on the closed interval from a to b and differentiable on the open interval from a to b. If f of a equals f of b, then there is at least one number in C in a to b such that f prime of C is equal to 0. Well, is it differentiable there? Well, let's use the short answer for that and actually calculate out its derivative. F prime of x, that will be, let's use the product rule. We have this quantity and this quantity, so we'll hold one of those two constant. Take the derivative of the other, so the derivative of this will be 1 over 2 x plus 4 to a 1/2, and then take the derivative of this, which will just be 1 by the chain rule, and add to that, that should be negative right there, right? And then add to that, we'll take the derivative of x, which is 1, and leave the other guy constant. Square root of x plus 4. Okay, so then that is going to be, when we simplify some things here, we have only x that's going to be left in the numerator, because we can take this negative exponent and send its entire base down into the denominator, x plus 4, and then we have this 2, which is also down in the denominator, plus square root of x plus 4. Now, on an interval from negative 4 to 0, in this closed interval, we have a continuous function, right? If x was less than 4, we would have an issue with that, because then we would start to get outside the domain of this function. But on negative 4 to 0, it is continuous. On the open interval from negative 4 to 0, we have the fact that it is indeed continuous. Now on an open interval from negative 4 to 0, can I put in any number into this and still get out some other number, right? So if I take any one of these numbers from -4 to 0, not including -4, not including 0, is my derivative defined there? Can I get a number out? And the answer is yes, I can. If it was -4 itself, I couldn't use that because that's outside the domain of this, because I would get division by 0. But it's not -4, it's any number which is greater than 4. Going all the way up until 0. So I can put every number into this definition for my derivative that I found and get out another number. So this implies that it is differentiable. Differentiable. So it's continuous and differentiable. It's continuous on the closed interval. It is differentiable on the open interval. So that's good. Now the only question becomes, are the endpoints equal to one another? And that is true, yeah, right? Because they're roots. They're both equal to 0. So that means that there has to be some point in between these two where a critical point lies. So I don't actually even need to find that critical point, but I could, and I know that it would indeed exist. So let's actually do it right now, just for grins and giggles. I have x over 2 square root of x plus 4 plus square root of x plus 4. And where does that equal 0? From -4 to 0. Well, let's find it. Oh, actually from the open interval, -4 to 0. Right, so that should be, I wonder if I can, oh, there we go. On this interval. So, well, we can subtract one side. 2 square root of x plus 4 equals negative square root of x plus 4. Whew. And multiply both sides by 2 square root of x plus 4, so I get x equals -2 times the quantity of x plus 4, because when I multiply by square root of x plus 4 on both sides, it will square it, getting rid of that square root. Distribute that -2 to both terms here. Oh. Do what I say, not say what I do. Let's see here. -8 equals x. Add these two x's right here to both sides. I get 3x equals -8. So x will equal -8 over 3, which is approximately -2.66 repeating. So, -2.66, hey, that's my number C. That falls exactly in this interval. Oh, I did it again. In this interval. And so, that's the value of C that occurs in between them. That I knew was guaranteed to be there because by Rolle's theorem, it had to exist. So, that is number, let's see, what number was that? 7. Okay? See ya.